what we've talked about until now is we came up with different ways to discuss and present center and spread of data. We have one way with the mean and the median. So if you have like a specific like data set, you can say, okay, here's the mean, here's the median. Or you can talk about standard deviation and 5-number summary. All right? Okay, let's talk about distribution. A distribution is a set of data that is organized into either a chart or a graph, right? When we analyze distribution, we focus on the center and the spread of our data, right? And we're going to be talking about one variable data, which is also called univariate. Not that big of a deal, just focus on the one variable data. Okay. In order for us to really know how to talk about a data set, we have to look at what it looks like, right? We have to identify the shape of it. So here you have 3 different distributions in 3 different shapes, okay? So look at the first one. The first one, here is the mean right here, right? And look at how the distribution is spread. So do you see how here we have a histogram? And then we have a continuous curve on top of the histogram, right? That basically takes the peaks. This is why, by the way, we can't have the gaps in the histogram, because then you can't draw this on top of it, all right? So look at what happens here. The majority of the data is where the peak is, and then there is a tail towards the left of this graph. Do you guys see it? Mm-hmm. Because the tail is towards the left side of the graph, and the left part of the number line is where the negative numbers are, we call this a negatively skewed distribution. Okay? We say negatively skewed or left skewed. Now go all the way to the right. Look at where the median is. Look at where the mean is. And then look at the tail. There's a tail towards the right side of the graph. That's where all the positive numbers are. We call this a positive or a right skewed distribution. And then you can see in the middle, look at where the mean is. And you see how the graph is totally symmetric around the mean. We call this a symmetrical distribution. Okay? All right. One thing to note is you have the mean, okay? You have the tail and the peak. The median is always on the side of the mean closest to the peak. So here the mean is to the right. The median is to the right. Here the median is to the left. Right? That's how it always shows up. So the median is always closer to the peak. Okay. When a distribution is symmetrical, the mean and the median are close together. So look here, mean and median are almost the same number, always, in a symmetrical distribution. In a skewed distribution, the mean is located closer to the tail than the median. That's what we just talked about. So mean closer to the tail, median closer to the peak. Okay, these are some important ones here, these 3. The median is less affected by outliers. Okay, so we call it a resistant statistic. The mean is more affected by outliers. This is a non-resistant statistic. So if like everybody in a class scores in the 90s and then somebody gets a 50, that outlier changes the average, right? That changes the mean. But it wouldn't change the median. The standard deviation is also a non-resistant statistic. Okay, so
can you graph like this? Is the standard deviation a part of these graphs?
Not, well, yes and no. You can tell visually. Unfortunately, that would have been 11.3, and we're not going to have time in this year to do it. But yes, yeah. But it's very much a part of this. It's kind of breaking my heart and Ms. Koh's heart that we're not going to get there, but it's okay. We're going to learn to deal with it. Okay. All right. This is important. Okay? I know. The one time, this one's important. If the distribution is symmetrical, we have to use the mean and the standard deviation. You need to just memorize this. Symmetrical, mean, and standard deviation. If the distribution is skewed, you have to use the 5-number summary. All right? That you have to use to describe the statistic. Yeah.
Oh,
Use it to describe the data. So for example, what we're going to do next is we're going to have a given set of data. We're going to graph it, see what it looks like, and then depending on what it looks like, we're going to say here is the 5-number summary, or here is the mean and the standard deviation.
Is it going to say where the mean and median is, or do we have to do it?
Well, you're going to graph it on your calculator and you'll know. Okay? That's sort of like the idea behind what we're doing right now. Okay. Everything is going to come together. This is why we do what we do in math, right? Everything comes together, yes. So the first lesson was all like, the first lesson is really just vocabulary. Now is when we're going to put it to use. Okay, so let's go ahead and put this into our calculator. So here, if you press the on button and the green spreadsheet button, go ahead and put those into your calculator, please. Okay, so here, so take a look. We have data ranging from the 60s into the 90s, right? I believe it goes, these are the lowest and the highest, right? 63 and 98. So what I actually want to do is I want to create a histogram that goes up by 5s, right? So stay with me here. I want to show you a couple of things to do here. So we're going to press the on button, right? This red one here, the on button that's highlighted in red. Then the purple icon for the spreadsheets, which is how, for the charts, right? Here's.
All my old,
it's okay. It opens up a new one for you.
No, it doesn't. I have all.
Okay, so look, when you click here,
Press tab and then it'll say live.
press tab, or just don't.
Oh.
Guys, look for a minute. Click on this. Literally, click on this, and then it'll give you an option. So this is the one. Okay. And then we're going to go to menu, plot type, and we're going to do a histogram. Okay. Now, but this one, like, look, if you hover on each bar, it'll tell you in brackets. So let me hover on this one so it's easier for you to see. It'll tell you in brackets that this is a class width from 75 to 77, and there are 3 in there. But I don't want them to go up by 3s. I want to do 5s, right? So here's what we're going to do. Go to menu. Go to plot properties. Go to histogram properties. And go to bin settings. And make sure you have equal bin width. Okay? Okay, let's do that again.
So 5.
Okay, look. Menu. Number 2 is plot properties. Number 2 is histogram properties. Number 2 is bin settings. Click on bin settings. Then you're going to want equal bin width. Okay? I want my width to be 5. Okay? And the alignment, 60.
How do we know?
Okay, so here's what it means.
Is this for like every case? Or just
No, I'm going to tell you guys. So here's what it means. All right? So now, look at what we have. Okay? So what I wanted to do is, here's my y-axis. Look, I'm going to unconfuse you. Look here. Here's my y-axis, okay? Here's my x-axis. I was saying before that I want to go in widths of 5. So I want my first one to be 60 to 64. 65 to 69, and so on.
Are you doing them 4 apart or 5 apart? Like the boxes?
I'm doing it.
Or the that part
It doesn't matter. That part doesn't matter. Just do the. Just make it equal.
Okay,
That's.
60 to
It really depends on how big your writing is.
65. 65.
Okay.
Any of these instructions can we put on the test?
No.
Okay. There's no way, Sarah. I just.
Okay. Now this. Okay. What I did here, I came up with using my own mind. It's 60 to 64, 65 to 69, 70 to 74, 75 to 79, etc. I came up with it using my own mind.
How'd you go from
How'd you go
70
80 to 89?
80 to 89?
Oh, sorry, I skipped one. 84.
I don't think I have enough room.
Yeah, it's okay. I misjudged it.
Unless I can just do the last one by like.
Let's just do that. It's fine. Okay, just for today. Okay? Okay. The big idea here is I looked at the data, right? It ranged from 63 to 98. There are 24 of them. And rather than, so that's the 60s, 70s, 80s, 90s. Rather than go by 10s and have 4 bars, I said, let me go by 5s and have that many bars. So when I go by 5s, right, this one, the class width is 5, and I started at 60, correct? That's what I did myself. Now, how am I going to tell the calculator that that's what I'm doing? It can't read my mind. That's why I do what I just did. So let me tell you again. I went to menu, plot properties, histogram properties. So think about it. You want to change the properties of your histogram. Bin settings equal bin width. I want my width to be 5 and the alignment 60. That basically says, like, where do you want me to start? Start at 60 is what you're saying. And then, how do you get rid of that? Okay. Now, I can't see up there, right?
If you just click on it, like, are the points the frequency?
Yeah. But I'm going to show you one other thing.
How do you zoom out?
Okay, that's what I'm going to show you right now. Go to menu. Misha, have a seat for a minute. I'll come over there in a sec. Go to menu, window zoom, window settings, just like your average f of x graphs. Window settings, you want x min to be 60, x max, what was my x max? 99. And here, let's just go up to 10. No. Your data, yes, it's 98. But in here, in my graph, in my axis, I went to 99, right? And y max, let's go to 10. Okay? All right. Questions. So 1, 2, the highest I think is like 3 or 4 or 5 rather. Okay, so the first one I have 1. Next one, I hover on the next bar and I have 2. Okay, so go ahead and draw that on your. We did this histogram, right? This one I just eyeballed it, right, just to show you guys the shape, but I want to go on here, right? This is how all of yours look, correct?
Yeah.
You can tell very, very clearly that this is a more symmetric graph, right? It's not a skewed graph. So that's the point of why we're doing this. This is symmetric, right? Because look at what it says here. It says construct a histogram and then use it to describe the shape of the distribution. It's a symmetric shape. Now, part B. No, don't draw the line. write a couple of sentences to summarize the center and spread of the data using either the mean and standard deviation or the 5-number summary.
Using the mean and
Okay, so look at what we talked about here. We said if it's symmetric, we have to use the mean and the standard deviation, right? This is what you need. So, since it's symmetric, we're going to use the mean and the standard deviation. So, we're going to go back on the calculator. You're going to go to where? To this tab where your data was. You're going to do menu, statistics, stat calculations, one variable statistics, number of lists, fine.
How did you get to where the data was?
It's the tabs here. You see the 1.2, 1.1? Hover and find your tab, okay? And so,
Mine? Do I go out of this?
okay, thank you. Because we've got like 25, the mean is 81.25, and the standard deviation is right there. It's 9.5. So here I say the mean X bar, you don't have to write the word mean, is 81.25, and the standard deviation is 9.5, right? So that was the point of this. Graph it. What does it look like? And then based on that, just give the values that it wants you to give. Okay?
So we don't have to write 2 sentences?
Yes, now we're going to write 2 sentences. Are we all okay with this one?
yes.
Okay. So lab grades, right? This is about lab grades, right? So what do these values tell you about how the students performed on this assignment? So basically, you know that the average or the mean of the scores was 81.25. And the scores were concentrated okay, look, 81.25 is somewhere over here, right? And the scores were concentrated between like 70 and 89. Do you see that? 70 and 89. And how do I come up with those numbers? You could either use the graph or the standard deviation is 9, right? So if I go roughly, right, down about 10 and up about 10, that's about 70 to 90, okay?
You say that again, please.
Yeah, between 70 and 90. So look, from this, the standard deviation is about 10. So like if from here, if I go like 10 down and 10 up, that's the standard deviation. Okay.
So that's all we write?
Yep,
Yeah.
all right.
That's all you write.